Hi, everybody. Here you go. 6.3. Here is our probably most difficult problem that we're going to be doing with solving systems by elimination. I could have done a slightly easier problem, but I want to show you how nitty gritty it's going to get. And that's going to be important so that way you don't hyperventilate. Few things. We're going to still follow this step 1, step 2, step 3, step 4, but because this problem is so intense, I want you to see them, I want you to embrace them and understand that I'm still following these steps, but I'm going to erase them because I need this space, okay? So step 1, we're going to go over real quick. Step 1, we are going to make sure the like terms are aligned. Step 2, we're going to add or subtract to eliminate a variable. We may need to multiply one of the two equations or both of them to be able to do that. And we are definitely going to see that in this problem. Step 3, we're going to substitute our answer from step 2 into step 1 of the two original equations to find our other variable. And step 4, we're going to write our final answer as x comma y and check our work. Okay, that's what we're going to do. But I now need to erase because this is going to be a very big problem, and I truly want you to see. One, how intense it's going to be. Like elimination problems and substitution problems can potentially take up half of your paper if you're not careful with how big you write. But then also like they are just that intense. And then number 2, we just plain need all of this board to truly see the complexity of what is happening. Here we go. So we have the equation 7x minus 12y equals -2, and 5x plus 14 is equal to 8y. First and foremost, we need to make sure our equations are aligned in terms of x's, y's, equal signs, operation signs, constants, okay? So we have to do a little bit of work on this one because our x's are aligned, but our constant and y over here, y term, those are not aligned properly, and neither are they here. So we got to do a little bit of work. It looks like I'm just going to deal with this bottom equation and subtract 8y and get 5x minus 8y plus 14 is equal to 0. Subtract 14 from both sides, and I get 5x minus 8y equals -14. So now our system technically is 7x minus 12y equals -22, and 5x minus 8y equals -14. So that was our first step. I'm going to rewrite this system now over here so I can see it very clearly with this now rewritten equation in there. So I have 7x minus 12y is equal to -22, and I have 5x minus 8y is equal to -14. As I deal with this, I'm going to try to deal with it with a couple of different colors. So that way we can maybe color code this stuff. Let's see if it works. I apologize for not having this already. Here we go. So 7x minus 12y equals -22, and 5x minus 8y equals -14. If we add or subtract these, if we just combine them as is, nothing's going to eliminate. It truly doesn't matter. Everything's aligned, but nothing's going to disappear. So what we need to do is we need to do that multiplication of one or more of these equations to make this happen. If I look at this, 7x minus 12y equals -22, and 5x minus 8y equals -14, there's a couple of different ways that I can deal with this. But the biggest factor is I need to decide what value I want to try to eliminate, okay? I could eliminate the x's by multiplying this top equation by 5, this bottom equation by 7. If I do that, I have to deal with this 22 and the 12 and that sort of thing with a multiplication of 5. I might get some really big numbers. So let's see if we can eliminate the y's and see if that will be easier. Our goal is to get the same number in front of these y's that I can then either add or subtract the two equations together and eliminate that y value. So 12 and 8, they have a common multiple of 24. So and they are factors of 24 essentially. So if I multiply this top equation by 2 and this bottom equation by 3, I could eliminate things. Now, what I also want to pay attention to is this. Aw, that's a crappy marker. Sorry, guys. What I also want to pay attention to is this subtraction sign, okay? The subtraction sign in both of them is going to sort of cause me a little frustration. So I am actually going to eliminate that frustration by multiplying this second equation by a negative number, so then it becomes positive and I can add them together and then it's easier. Subtraction is going to cause me potentially more problems than addition would. So what I'm going to do is I'm going to multiply this top equation by 2, okay? And then I am going to multiply this bottom equation by -3. If I do that, this y term will become -24y or positive 24y, depending on the equation. And then things will disappear. Now notice, I had to multiply both equations to be able to do this. And now you can already see why this is going to take a little while. So I'm going to rewrite this top equation with this 2 factored into every single one of these terms. So I'm going to rewrite this as 14x minus 24y is equal to -44. This bottom equation is going to become -3 times 5 is -15x plus 24y is equal to -3 times 14. What is that, 42? 42. And now I can actually do some work. I can combine those two equations and I can solve for x or y. In this case, it looks like I'm going to be solving for x because I'm eliminating the y's. So again, I multiplied this bottom equation by a -3 so that way I could add these two. So 14x plus a -15x would get me -1x. -24 plus 24 gets me 0 y's. -44 plus 42 equals -2. So I get -1x is equal to -2. Divide by -1, divide by -1. I get x is equal to 2. That's part of my solution, okay? 2 is part of my solution. Now here's the kicker. I am not going to put this 2 into this blue equation or the purple equation here. I'm going to put this 2 and solve for the y value into one of these original equations. I'm going to do that because I want to potentially eliminate some of this extra potential mess that I made. I might have made a mistake, and it's important that I eliminate that mistake, or at least I acknowledge that a mistake could happen there by going back to the original problem. So I'm going to take that -2 and I'm going to put it into one of these original equations. Notice, I now don't have to focus on that, and I can clean up my board a little bit. So 2 needs to go into one of these two. I'm going to pick this one because 2 times 5 is nice. I like 2 times 5. I like 2 times 7 too, but 2 times 5 gets me a nice number 10. So 5 times 2 is 10, plus 14 equals 8y. 10 plus 14 equals 24, equals 8y. Divide by 8 on both sides. I get 3 is equal to y. So my final answer, 2, 3. I'm now going to check my work, and I'm going to make sure everything truly does like figure itself out properly, check itself out. So I'm going to say 7 times 2 minus 12 times 3. Does that equal -22? Need to ask myself that. So 7 times 2 is 14. 2 times 3 is 36. 14 minus 36 gets me -22. That one's good. Awesome. This next one down, 5 times 2 plus 14 is equal to 8 times 3. 5 times 2 plus 14, we figured it out up here, it's 24. 8 times 3 is 24. So this is my finished product. Or this is my finished equation, or finished point. Goodness sakes, I can't talk today. That's my finished point. That's my intersection of these two lines. That's where these crossed, right? At this exact point. Intense, very much so. So, I'm an intense person. This is an intense problem and solution method. And it's going to have to, and you're going to have to do it. This is totally a proficient problem for algebra. And so I expect you to be able to do this. If you have any questions, do not hesitate to ask. As always, I'm sorry this video is so long. It's huge. You know I'm long-winded. I'll talk to you later. Bye.